Hello again, you sick, twisted weather freaks. Welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT, from WX Risk, the commander of chaos, the colonel of confusion, the captain of catastrophe. Let's talk about weather. And of course, we will be talking about Dorian. That's the prime topic here. And this important hurricane that now has become a Category 3, and even now is probably intensifying as I speak. Just briefly remind you, this is how you can reach me on my Verizon or my Gmail. There's my local Twitter account, and I'm located in Richmond, Virginia. And the Facebook page has about 280,000 likes, and often I can get a reach up to about 3.8, 3.5 million, something like that. So here in Weathewr, of course, remember we do more than just look at models. We like to think outside the box. And the thought for the day comes from the great Nasib Talib. If you take risks and face with dignity, there's nothing you can do that makes you small. If you don't take risks, there's nothing you can do that makes you grand. Nothing. Pretty deep thought. I'm a big Black Swan Talib fan myself. So here's the 2 o'clock advisory. You can see that major hurricane getting into Florida, then making a turn to the north. The Hurricane Center still had it coming inland and then turning north. The 5 o'clock advisory here has it closer to the coast, and that's because the models have shifted. And we'll get into that momentarily, but that's what's happened here over the last 3 or 4 or 5 hours. This year's latest satellite picture, a very recent one here this afternoon, you can see this sucker is cranking. Look at that baby. And what's interesting is that the orientation of this thing, again with the cloud mass, it tells you where it's going. Notice how it's oriented in this direction. See how the swirl goes? So that's one of the reasons it's going that way. A lot of times you see a hurricane coming up the coast, you see the cloud mass, doing one of these things, and the cloud wisps are going to the north. But in this case, it's going due west to east. So, and you can see that more in the my next image where it is relationship to the U.S. There's Florida down here, as you can see. Well, I make sure you can see Florida because there's a lot of clouds over it. Yeah, you can see Florida right down in here. Okay, and there it is. You can see, look at the cloud mass going in that direction. So now the other thing is this feature right here. That's an important feature because that may have had an impact on what happened with weather models today. So we're going to get into that. Here's the infrared picture of that sucker. You can look at that eye, baby. That thing is cranking. Very impressive looking system. Meteorologists would like to get excited about it, but and tropical storms and hurricanes and what have you. But let's be careful here. Remember, if you've ever been in a major hurricane or a disaster like a big tornado, it's a life-changing event, and everything that happens afterwards is a different part of your life. So keep that in mind. It's that bad. It's like being in a war. It's that sort of fundamentally changes your life. All right, this year's latest recon, you can see the pressure's dropping, and look at the purple colors here at the bottom of the scale. You can see the flight level winds up to 83, 85 knots, as close to up to 100 miles an hour. And the latest recon, this was from earlier this afternoon. You can see that the winds peaked. Let me get my marker out here so you can see it. Look at the right here, the peak here, over 95 knots. Again, very close, and the pressure down there almost to 965. So it continues to intensify. This is the surface winds up to 100 knots here, a peak gust to 100 knots, and so it's really cranking, no doubt about it. Now this was the morning European model from early this morning, and I looked at it and I saw a bunch of clusters here. If you look at it in the 3 different clusters, okay, we have one cluster which was taking it rapidly, well, not rapidly, but showing a slow turn here, and then keeping it mostly off the coast, even passing, as you can see, this is Hatteras. Most of this was passing south of Hatteras, and then a few up close to Hatteras, but this was generally one cluster in here. And then a second cluster was doing the same thing but taking a wider turn. Okay, this would be very, very bad news for the orange citrus crop in Florida, and then the cotton crop in Georgia. And then for the time it got up into eastern North Carolina, Virginia, this would be a much weaker storm, just a rainstorm. And then the third cluster was over this and then turning it up into Georgia, taking it out over the northeast Gulf of Mexico, the Florida panhandle, then turning it north. Now that would be okay for the orange crop in Florida to some degree. It wouldn't be a huge hit because it's only cutting across southern Florida, but it would be very bad news for the Georgia cotton crop. All right, so that's what the morning European was showing, okay? Now, this here is the afternoon GFS ensembles, and you can see that from this morning, it was all most of the spread was taken to Central Florida. There was only one or two models that were actually turning it to the north. Everybody else was still driving it into Florida. You can see that, and many of them were taking it to the Northeast Gulf. So that was definitely supported. Cluster number 3 there. The GFS was supporting that. Now, this what happened this morning when I was doing my agricultural and commodity forecasting. This cluster of intense thunderstorms, this is what's known as an MCS, a mesoscale convective system. This cluster of powerful thunderstorms developed in the overnight hours in Kansas and Oklahoma and Missouri, dropped a lot of rain in a short period of time in northern Arkansas. But this feature, which is what we call a mesoscale feature, was missed by some of the climate models over the past couple of days. And the end result is that it may have had an impact. Now, a couple of days ago when I did my video, what I saw, the reason why I believe this was going to hit straight into Florida was because of the building heights here, the energy, the building atmosphere, 500 millibars. This shows height increases here. So this was a big bulge here of heights building in, what we call the Bermuda High. And that would force the hurricane to attack a more westerly direction and take it straight into Florida. You can see that's what it was doing. Now, the real reason why that isn't, I had to push you out because I'm pointing this out is to show you what's changed. So that was the Bermuda High building into the East Coast. But this piece of energy here, which caused the showers and thunderstorms, can be seen clearly here. Now, this is the overall steering flow for north for the U.S. and Western Atlantic Ocean. So let's take a minute to look at this here. I got to get a good marker so you can see the right color here. I guess we can use, yeah, that's good. So this piece of energy here, see that? That piece of energy shortwave is the system which brought the thunderstorms into Kansas and Oklahoma, and Missouri, and Arkansas. So what that's doing is that's attacking the western flank of the ridge here. As it moves through, it's going to attack the western flank. So it's now weaker, so that means it might have a chance to come up and go like this. So in other words, instead of having the hurricane go around the western flank like this, because this feature is attacking it, the global models think that this part of the Bermuda High is now weaker. See? This part is now weaker because of this attacking it. That means that the hurricane can now make a sharper turn to the northwest. That's what the global models are saying. Is that correct? That's the issue. Okay. Now here we can see it again. Now this shows us our shear, and there's very little shear in the Southwest Atlantic Ocean, as you can see. You were looking the dangerous sign, which you don't want to see for if you want the hurricane to intensify. I don't know who the hell would want that, but you want to keep it under 10 knots down to 15 knots down in here. You can see this is all very, very good area in here. Now here's a strong shear. There's a jet stream right in here, very powerful, but that's staying to the north. So as it approaches Florida or northern Florida, Georgia, it does its turn. It's in very, very good conditions in terms of atmospheric shear, not ripping the top of it off. That's what shearing does. In case you're not familiar with that, the shear in the atmosphere means that the winds are coming at different directions, different speeds, and it causes the thunderstorms to get disrupted, which weakens the hurricane. Okay. Now this shows the shear tendency, what's going on, what's expected to go on here. As you can see, the negative numbers in the Western Atlantic Ocean, -5 in and around the hurricane. Here, look at all this. That's showing the shear is decreasing, going down. You see, that's decreasing tendency here. So that's even better for the hurricane to intensify. All right, let's take a look at what's going on here. This is the atmospheric pattern here this morning, Friday, August 30th. And we can see, there's our big trough right here, monster trough in the jet stream. Look at this baby. Wham. Okay, that's why we were in the 50s in Virginia and some 40s in Pennsylvania, New England, New York State this morning. Nice, cool air mass. Here's our big ridge here, and there's the Bermuda High right here, and this baby right here, that represents Dorian. Now, that's from this morning, early this morning. Obviously, it's gotten bigger and stronger since then, but that's where it is. So it goes around this feature and then maybe makes a turn. There's a gap here. That's what the models are looking at. Now this feature here, this next image shows us for Tuesday evening, Monday evening at 8 p.m., a Labor Day evening. And you can see there's Dorian right along the coast, hitting close, somewhere close to Palm Beach. And there's that gap. So these blue lines I drew here, these represent any piece of energy, a short wave. This is a short wave here. So what's coming down is that these things are coming through and they create a weakness here. See, it's created a weakness in the atmosphere. This little bend here, that's a weakness. So the hurricane gets to turn into it. And then this one's coming down, and that one's also going to come through and kick it out to sea. So that's what's happening here that's why the models are turning to the north. Let's take a look at this. Now this is the European from this afternoon. There it is on Tuesday, September 3rd. Okay, not Labor Day. It's slowed down a little bit, as you can see. And then here we have the evening of September 3rd. Now look, it's clearly turned a little bit to the northwest, as you can see. You look at the positions here. To give you, in case you're not certain, there's the island here, the Bahamas. Now look where that island is here. So it has turned to the northwest at this point, according to the afternoon European. And then here we can see it's now turned way sharply to the northwest. And this image up here in the upper left, we're talking about this image right here. Okay, this is Wednesday morning, 8 a.m. And then this is Wednesday evening, Thursday morning, 2 a.m. Just after midnight. You can see it's parked right off the South Carolina coast. And it's doing this. Okay, and then now, some people are going to say, well, it's going to parallel the coast, which it might. I suppose it could. Let me clear this out. But the issue is, and you can see the model here from this morning was clearly showing that. You can see it's got the system right on the Georgia-South Carolina coast and in between the two ridges. So what's happened is the Bermuda High did not build all the way in like I thought it was going to. So it's only out to here. And then we have the other big heat ridge, heat dome in this way. And there's a gap, and this one piece of energy is moved on through, and here comes the next one that's going to kick it. So before it gets too far north, this feature is going to come along and slam it out to sea. No doubt about it. Here's the European. There's the cold front. This is now Thursday, September 5th, 8 o'clock in the morning, about 6 days from now. Look at the big high over Michigan and the Great Lakes. That's a pretty big high for early September. And there's the cold front, very clear. And that high is going to move into New York State and New England and push this thing out to sea and prevent it from coming any further north. If we buy the European scenario, we can see right there it's being kicked out to sea, moving off the coast. Does it go over Hatteras? Does it not? Hard to say. It could. It may pass just south of Hatteras. A lot of different possibilities here, but I wouldn't see it getting north of Hatteras. Slide 20. Here we can see this is now a Friday morning, September 6th. This is the afternoon European. This is a week from today, okay? And look where it is. Nice, strong Category 3 hurricane just south of just south of Cape Hatteras, moving in a northeast direction. Look at the high over Maine. See what it's doing? It's forcing it, blocking it. That high over Maine and New England is protecting Virginia and Maryland and Delaware and Pennsylvania, New Jersey, New England. Now there could be gusty winds into southeast Virginia if this is correct. And again, Hatteras could take a hit. Eastern North Carolina could have a significant time. But of course, remember, if you're in Elizabeth City or Greenville or in the Albemarle Sounds, you're on the northwest side of this thing. So you're not getting the big direct hit here, as long as it stays south of Hatteras. Okay, now here is the afternoon European ensemble, and we can see a big shift. Let me go back to the original European ensemble from this morning. Look at the difference between that. See how scattered it was from this morning? And now we have that. Everything is shifted. Notice there's almost no members now taking to the west coast of Florida. Everything is either on the coast of Florida or just off the coast. And most of these lines are, again, south of Hatteras. Most of them stay off the Georgia coast, the South Carolina coast. Not all, but most. South of Wilmington, that sort of thing. So if that's correct and you want to follow the mean, this would be almost this would be like a Matthew type of situation in taking that round curve. But it looks like, so that's something to watch out for, is the Matthew scenario. A lot of people talking about it. It has some validity, is some concern. Now, that being said, this is the British model, which also does very, very good with hurricanes. Notice the afternoon British model, called the UKMET, has it making landfall on Tuesday night. And then here we can see, here we can clearly see it goes over on Wednesday morning in central Florida. It's not out to sea, and then it goes around over, it actually goes right over Savannah. This would be a disaster for Savannah. This would be really bad if this were to happen. And then very close to Charleston and maybe passing close to Myrtle Beach. Because what the difference here is the same turn. The difference is that here, the British model is taking it actually onto the coast. It's the same turn. It's just when is it going to take place? How sharp is the turn? All the models have the turn. Where? When? How sharp? These are the questions. This is the GFS ensemble. from this afternoon. Now the red lines show the different areas of low pressure. So you can see all the clusters, and the yellow and the orange shows a big cluster of them. So you can see there's a big cluster on the ensemble mean. This shows on Tuesday afternoon, 2 p.m. It's over land, just south of Orlando, very close to Orlando. You can see that. A few members are still off the northeast Gulf of Mexico, but the vast majority of the GFS ensemble members are right over Central Florida. Here we have, let me move this up. This is now Wednesday evening, September 5th. There it is, almost over Savannah, Jacksonville. That's a pretty serious hit for those guys. Okay? And now remember, also, in case you don't know, remember the coast here is concave, right? The coast here is concave. So the hurricane coming up this direction is going to drive the water into the coast. So that's a particularly bothersome scenario if that's correct. Okay. Now, so in other words, we have, everyone's talking about Matthew. Matthew is going to come up parallel to the southeast coast, going to flood South Carolina, North Carolina. Okay, because many of the global models, the regular ones, the operational GFS, the regular operational European, the British model, have shifted Dorian track to the east and shows either a miss of Florida's east coast or a glancing blow, and then turn it to the north. Many are saying, hey, this looks just like Matthew. There is something wrong with that sort of thinking. There have been a lot of hurricanes which have stayed east of Florida, which have not become like a Matthew track for the Carolinas, where they've had that tremendous flooding. So Matthew sticks in your head because you went through it, but you have to realize there's a lot of history and other possibilities in climatology out there where hurricanes have not done that. So it's okay to be worried about Matthew, and who knows, this might take a track similar to Matthew's, but don't automatically assume that. That's my point here. The other issue is the Irma scenario. Now let me tell you what I mean here. Now this is the Matthew track, as you can see. Now here, notice that it stayed. Now notice that Matthew is a little different. It was doing this the whole time. Now, Dorian is doing this and has to make the turn. Now, the question is, is Dorian going to go like that, or is it going to do this like Matthew? That's the issue. Okay, so I understand that. We don't know which one's going to be. But it is different in that Dorian is going due east to west, not coming up from Cuba. So keep that in mind. So there's some differences there. Now, this is Irma. Now, why are I bringing up Irma? If you remember, Irma was originally supposed to go up Miami, the east coast of Florida. You see that? And instead, it stayed west much longer than the models forecasted, and then it made its turn and went up the west coast of Florida. So again, the global models were correct in showing the turn, but it was too soon by about 24 hours. And that's why Miami did not get the big hit everybody thought it was going to get, but instead Fort Myers did. So again, the global models can get the turn correct, but if it's delayed by 12 hours, by 24 hours, that's a huge difference. If the turn is delayed by 12 or 24 hours, Central Florida gets a big hit, and that means when it comes up into Georgia and southeastern U.S., the big rain and wind on the coastal areas is going to be much less, if you're worried about that in coastal Georgia, South Carolina, North Carolina. If it comes inland into Florida and then turns north. So this turn is really, really important, folks. It's hard to overemphasize how important it is. Let me show you. This was the Irma track from September 2017, 2 years ago. Notice, you see how it's going west of over Miami. Everyone's freaking out. Oh my God, the big Miami hurricane finally is going to show up. Then it got delayed because the turn was late. So the hurricane had to shift the track again. Now it's going through Central Florida. Okay, and then it went through Eastern Florida. So the track is, it does that. In summary, let's get to the summary here. Okay, did the various global models today overreact to that big MCS, the thunderstorm cluster, that was in Kansas, Missouri, Oklahoma, and Arkansas early this morning? They might have. And because they may have weakened the ridge in the western Atlantic, the Bermuda High, too much, and that's why they may have turned it too sharply to the north. We'll know tonight or tomorrow morning, but that is something to keep in mind. Okay? There's a much higher percentage chance that Dorian, as it approaches the Florida coast, will turn from west to west-northwest, to northwest, to north-northwest, then north, then northeast, then east-northeast on September 3rd and September 4th. The question is when? And how sharp is the turn going to be? Is it going to be a wide turn, or is it going to be a very sharp turn? Don't know. Both scenarios are possible. Point number 3, a delay of 18 to 24 hours in that turn from what, let's say, the European model or the GFS is showing, places the eye over the south central interior Florida or central Florida. Again, a delay like we saw with Hurricane Irma. If Dorian I stays off the Florida coast, east coast completely, the odds of it making a much sharper turn to the northeast and east northeast and passing south of Hatteras goes way up. Okay? So, and finally, last question is, how close does Dorian get to Hatteras? Remember, we have that big, strong cold front coming down next Friday with that big ass high over Michigan and New York State, and that's going to drive that cold front and kick it out to sea. So that is coming. We have these big cool air masses been coming in for the last 2 weeks in August. It's been very nice here in the mid-Atlantic and the Ohio Valley, New England, for the last 10, 12 days. And that's going to continue as we go into September. But these highs are real. They are coming down. So there's going to be a big high and a big cold front, which will come in by next Friday. So no matter where Dorian is, that front will kick it out to sea. That's a fact. Well, as much as it can be when you're dealing with weather predictions. This is meteorologist DT from Weather Risk. I'll talk to you soon.